Okay, so welcome to the lecture of this finite volume method. So today we will finish the discussion on the mesh, and so far what we have discussed on the structured mesh, their orientation, how to calculate the surface normal vector, how to calculate the gradient and the other terms. So today we will move to look at the similar things for the unstructured grid system. Now, if you just recall from our previous lecture, this is where we actually stopped. We have had this kind of, just to give you a brief overview so that we can be on the page to continue for the unstructured grid. So, this was the structured grid system that we have discussed. So, the figure A, which actually was a local indexing, where you have a element at I j location, and that element at I j location and then the ahead of it I plus 1 j location, behind that I minus 1 j. So, the local indexing means you move along the I that and j direction, that is essentially in your coordinate system or the referencing system, it is a x and y direction. Once you move along them, so you got some local indexing for the system. Then from local indexing we have moved to the global indexing, and how it is done? It was a 2D system. So, the 2D system, it was done in a simpler fashion, that I and j count are taken into consideration, and then we have done the local to global mapping. So, if you just look at this picture, which will give you an exact idea, you have a 2D domain where you move from I direction and then j direction, and you have an element at I plus I j location. So, essentially this is your I j location, and at I j location then you kind of consider this surrounding element to discuss about that these things. From this is where it is a local indexing. From local indexing to global indexing is mapped like this. So, this is how the global indexing is done. The reason being, your final linear system or the discretized system essentially is going to give you the linear system like Ax equals to b, and the matrix A, this only can be handled using the global indexing system, and the x vector, which will be all the variables for the element from 1, 2 to whatever the n number of elements, total n number of elements, or n t, the total n number of elements. So, the variables for the each elements, the phi 1 to phi n t, these are also in the global indexing system according to the right hand side vector. So, since the local matrix requires the global indexing system, it is always necessary to transform the local indexing to the global indexing. So, that mapping needs to be done, and once you do that mapping, then you can see the stencil around that particular cell where we are kind of concentrating our discussion, that essentially this I j element, which is sort of mapped to this guy in the global indexing system. So, each local index has a global index, and the mapping is done as we have seen right now. So, this mapping actually helps to build the linear system or the global matrix A, which would be the total dimension of total number of element by total number of element, since it is 2D. So, each local index has to be mapped to a global index. Similarly, for this particular example also, this element has been mapped to this element, which essentially we call it the nth element. Then accordingly the other elements which is surrounded by this element, and these are the number of elements that requires to be considered or that need to be considered while doing the discretization for the gradient calculation. So, then the one which is ahead of it, which will be n plus 1, the one which is behind this n minus 1, and so on and so on. So, one is in the upper side, one is in the lower side, one is this corner, one the. So, this if you recall from our previous lecture, this goes in a nice directional. So, north, south, east, west, and then according to northwest, southwest, southeast, northwest. So, this is how you recur. Now, third option is that, I mean, in the sense from local to global indexing. So, that helps you to keep track of each element in the system. Now, once you do that, you have to get to the discretized system. So, from there you look at a particular element interior inside the domain or in the interior field, or any element which belongs to the interior domain which does not belong to the boundary, because the boundary elements needs to be treated separately since there is a specified boundary condition. So, then from there you come down to a discretized indexing, where discretized indexing you can see this direction pattern is kind of represented. So, something which is ahead of it is east, behind it west, upper side north, lower side south, southwest, northwest, and this particular element is connected with 4 faces and the neighboring element like east, west, north, south, and those corresponding or connecting faces are marked as a small e, small n, small west, small south, and then we derive the required gradient calculations, and finally we discussed about the pseudo algorithm. And if you go over it quickly, is essentially you look at the local indexing, then you initialize the gradient, then finally you look at each faces and calculate the flux, then as per the sign of the normal vector you or the orientation of the vector, you take care of the proper sign of that flux. So, when you add or subtract according to that, and finally you divide by the ambient volume, so you get the flux. So, that is how is done for the structured system. Now, this is how it is obtained. Now, if you move to the unstructured system, this is purely a 2-dimensional again unstructured system. This is unstructured grid. Now, why it is unstructured? Because the elements are not very nicely ordered as we have seen for the structured cases. So, they are sort of randomly oriented, but effectively they must represent the physical domain. Now, what happens to that? This gives some sort of a flexibility. What kind of flexibility? In the sense that you can handle any kind of complex geometry. So, that is a added advantage that you have over structured system, because the structured system it is very specific to sort of a regular Cartesian kind of system, but in the unstructured grid any complex geometry with any sort of curvature, cut, edges you can easily handle, but it comes with some sort of a cost, okay, because nothing comes at free of cost. So, when you can handle a complex geometry, obviously in an unstructured system they are not numbered sequentially. So, your local connectivity or the connectivity is must. So, local connectivity information needs to be kept in your data structure. So, that is why it does not come with a free of cost, it comes with some sort of a cost or price, because your handling of data structure become little bit, I mean if not cost effective, it is essentially some involved handling is required. Why? Because since these elements as you see 1, 2, 3, 4, 5, 6 they are all randomly located. So, you need to take care of that certain all the element connectivity. So, element connectivity in the sense that information of each element, its faces, its node and other geometric information. So, for a particular element, if you consider this particular element, so you need to, and also other geometric information which includes all the neighboring cells. So, one particular element in an unstructured system needs to have all these issues or the information. So, one has to take into account all this information in its data structure for the programming. So, if you look at or immediately compare between a structured and unstructured, you could see the involvement which required in this kind of system. Since in a structured system it was nicely ordered. So, if you just keep track of local indexing like I, j, from there you can always go back to global indexing and vice versa. That means, from local to global or global to local transformation is much easier, whereas if you look at in the unstructured grid, that is not like straightforward. So, it requires some sort of an involvement while keeping track of elements connectivity, local connectivity, and then accordingly from the local connectivity to the global connectivity. So, the elements which are surrounded by the other elements, you need to keep track of that. So, which essentially comes with some node information, face information and other information. So, that means, in a unstructured system there is no direct way to link various entities together on their indices alone. So, this is a very important statement. So, that is why in an unstructured system there is no direct way to link that. So, that leads to a must condition is that your local connectivity has to be defined explicitly along with this other information like faces, node, etc. So, if you just concentrate on a particular element, then we can looking at this complete domain. Now, you can look at this particular element, element number 9, and then if you see how things are done, that would be give you an exactly or clear idea how the connectivity and the flux calculation needs to be done for this interior element. So, let us concentrate on element number 9, and if you look at that element number 9, the 9 is surrounded by another. So, this is the element number 9 is surrounded by 6 elements, and those are 1, 2, 10, 11, 8, 6. So, these 6 elements, they are kind of situated or sit alongside with the 9, and there are certain common faces with each of these elements. So, while doing the calculation of the flux, one needs to take into account that. Okay. So, what information one has to do that, you have to have some sort of a geometric connectivities, which means your connectivity between element to element. So, that means here 9, which is kind of surrounded by all these 6 elements. So, the information or the geometric information which requires is the connectivity between element to element. Then another important thing is that element to faces. Okay. So, that means if you again come back here, this is the element, if 9 is connected with 11 through this common face. So, this face connectivity also needs to be tagged upon. Then you need faces to element. So, which I just said element to faces, it is the vice versa of that, faces to, then element to node. That means this is the element and then what are the vertices it has. So, the node information. So, once you have that, then only you know how it is connected with the other element or the associated element along with the which faces, because the node information is important, and so on. So, these are the very very important that. So, essentially if you look at the programming point of view, the data structure. So, data structure needs to be defined for element or rather number of elements, faces and nodes, and which also includes the information about neighboring elements. Okay. So, essentially this will lead to your local and global indexing. So, from here you can have an estimate of your local and global indexing. Okay. So, we will stop here today and we will take from here in the follow up lectures. Thank you.